In today's video, I'm going to examine the performance capability of a single LSI SAS 2008 SAS controller chipset with a SAS2 expander. In a previous video, I had shown you the performance capability of two LSI SAS 2008 controllers with 16 hard drives in a variety of different configurations. What you see on the screen right now are the results from those benchmarks of the previous video. Now, a single magnetic SAS drive, in this particular case, a 4 terabyte Hitachi SAS drive, can only do about 200 megabytes per second in each direction, read or write. And so if you look at the capability, the theoretical capability of 6 gigabit SAS2, and considering that you have 8 of these SAS2 lanes from the HBA controller to the hard drives, that gives you a total of a 2 times 4 times 6, so that's 48 gigabits per second. And that translates to about 6 gigabytes per second. And so even if you have 16 hard drives that can do 200 megabytes per second, if you multiply that, you'll get about 3.2 gigabytes per second. So 3.2 gigabytes per second is definitely less than 6 gigabytes per second. So the question then is, do you really need two LSI SAS 2008 controllers, or can you simply handle the same type of performance level with a single SAS 2008 controller with an expander? Right? And perhaps there's some overhead with the expander, perhaps there isn't, but today we're going to find out by running the same exact test that I ran in the previous video, but in a system that is actually the same exact system, same hard drives, same LSI SAS 2008 controller, except that there's only one of them now instead of two, and the hard drives are now connected through this SAS2 backplane from IBM. Alright, so let's take a look at the hardware here. As you can see, I've only got one SAS 2008 HBA card right now instead of two like the last time. I have an IBM SAS expander. It's a SAS2 expander that has 2 inputs from this HBA, so that's a total of 8 SAS lanes, 4 lanes per input. And this expander then expands to 4 output ports, each containing 4 SAS lanes, which run to the 16 hard drives here. And these are the exact same hard drives that I used in the last test, so that really the only variable that has changed now is the number of controllers and the backplane that is now between the hard drives and this single controller. So I've got this new spreadsheet here where I will fill in the data that we gather from today's benchmarks, and then we'll be able to compare that against the numbers from the previous benchmark to decide on whether it makes sense to, if there's any advantage at all in having 2 controllers versus a single controller with a SAS2 expander backplane when you have a disk array of traditional magnetic spinning drives. Alright, so now for the single disk performance, I'm keeping the numbers from the last video simply because they don't really change when it's just the performance level of a single hard drive. I've actually tested this outside this video, and the numbers were almost identical, off by 1 or 2 megabytes per second or something like that. So that's just kind of normal variance. So I'm in the interest of keeping this video a little bit shorter, I'm just going to reuse the numbers from the last video for a single hard drive. Now let's go ahead and look at doing 8 hard drives in RAID 0. Alright, so for the RAID 0 with 8 hard drives, I'm going to pick these first 8 hard drives, right? So that's B, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so B through I. Alright, so let's go ahead and create that. So I'm going to create a dev md0, And RAID devices, we're going to have 8 drives, RAID level 0, and assume clean. Okay, and this is going to be B through I. Okay, and now we have the array started. Let me just verify that it's there. Okay, look, everything looks good, and it's using the same 512K chunk size as before. Let's go ahead and format this. Okay, formatting is done, and let's go ahead and mount this. I'm going to mount it in my Data1 directory. Alright, so the first test that we run is a DD test with 1 megabyte records. I'm just going to pull this up from previous history, so we're running the exact same test. Here we're going to read in a bunch of zeros, write it to a file called speed test with a block size of 1 megabyte, and we're going to do 10,240 of this, so about 10 gigabytes. Alright, let's go ahead. Alright, so we got about 1.4 gigabytes per second. I'm going to go ahead and drop the cache, and then we're going to read that back, also at 1 megabyte block sizes. Alright, so we got 1.5 gigabytes per second. Let's go ahead and record that. So the writes were 1.4 gigabytes per second. I'm going to record that in megabytes, so I'll multiply that and record that as 1434. And the reads were 1.5, so I'm going to record that as 1536. Alright, now the next test we run is IO zone. So I'm going to do a single threaded test, and this is the exact same thing as last time. 1 megabyte records. We're going to do the write test, read test, and random IO test, single thread with 16 gigabyte file size. Now, in case you didn't watch the previous video, this is a system with only 4 gigabytes of RAM. So this 16 gigabyte file is definitely going to exceed the caching capability of the 4 gigabytes of RAM on this machine. And so therefore, this is that file size was chosen specifically so that we can avoid the effects of caching in RAM. Alright, so let's go ahead and run this. Alright, the tests are done. Let's go ahead and record these numbers. So for the initial write, I'm going to, again as previous, I'm going to take this average number and I'm going to round that to 2 since it was 0.5. So I'll record that as 1489. And for the read, take this number and I'm going to round that to 800 there. I'll record that as 1456. And for random writes, that's this number down here. I'll record that as 565. And for random reads, I'll record that as 93. Alright, so just to take a quick comparison of this SAS expander setup versus the two SAS controllers, we're really looking about the same numbers. Nothing's really changed significantly. If you look at 1400s to 1500s, 1400s, 1500s, 1400 to 1400s, about the same, about 500-ish, and about 100, 500-ish, about 100. Yep. So really, doesn't seem to be any difference at this point with a RAID2 of 8 hard drives. So now let's go ahead and do the 16 hard drive setup in RAID2 and see if we see any difference there. All right. I'm going to stop the array. Oh, I probably should unmount it first. And we'll stop the array. And let me, oops. Zero out all the super blocks. All right, so let's go ahead and create a 16 disk RAID2 with all 16 hard drives B through Q. All right, let's take a look. All right, and format. Okay, formatting is done. Let's go ahead and mount this. Okay, so let's run our DD test. All right, we got 1.5 gigabytes per second writing to the 16 drive array. And let's drop caches. Then we're going to read it back. All right, we got 2.3 gigabytes per second. That's pretty good. And in fact, I think that's probably about the same as what we got last time. So let me record this first. And so I know 1.5 gigabytes, that was what we had here. So I'm just going to record that as the same number. And then for 2.3, let's do the math a little bit here. I'll record as 2355. 355. So let me just confirm and compare that to the previous. So 1434, 2355. Yeah, in fact, sequential writes looks a little bit higher, not by a whole lot, but the sequential reads is identical. So we're really not seeing any advantage to having two LSI SAS controllers versus a single controller and a expander backplane. But let's go ahead and run the IO zone and see how those results look like. Okay, the results are in. Let's record these sequential writes, averaged about this much. I'll round that up. So that's 1676. Now for the sequential reads, I'm going to use the average here. Okay, that's 2059. And for random writes, record that as 1194. And random reads, record that as 96. Okay, so with 16 hard drives in RAID 0 on a single controller, I should actually change this description here. So one controller plus expander. Let me change this here to one controller plus expander. Okay, so if we compare this to the previous results, sequential writes is actually a little bit faster. Sequential reads is the same. IO zone shows sequential writes being 1676, so about the same in sequential writes. Sequential reads 2059, 2139, so a little bit slower, but you know, that's probably within any testing variance. Random writes at 1 megabyte records 1194. Random writes 1416. So that's actually might be significantly, well, not significantly, but at least noticeably lower. That seems more than just kind of testing variance. So that's 1200 roughly, and this is about 1400. So there might be some performance loss in random writes, and then random reads has always been the same. We've never achieved anything above the level of a single hard drive for that. Okay, so so it looks like for sequential access, you know, having the expander in one controller is pretty much identical to having two controllers, but for random access, there might be a slight performance degradation without having two controllers and having an expander between. So that's an interesting result. Let's go ahead and run the tests for the RAIDZ2 sets. Alright, so let me stop this RAID array. Oops, keep forgetting I have to unmount it first. And let's zero the super blocks. Okay, so we've got B through Q, and for the first RAID Z set is 8 hard drives, so I'm going to pick the bottom 8 this time, and so that will be zpool create, let's call it data, RAID Z2 dev sd j through Q. Alright, let's see. Alright, that looks good. And let's go ahead and create our testing data set. Alright, and over here I'm going to switch from running the regular IO stat to zpool IO stat. Alright, so first test is our DD test. Let's go ahead and do that. Alright, let's drop some cache and read that file back. Alright, let's go ahead and record this. So we got 550 for sequential writes, 975 for sequential reads. Now let's run the IO zone. Alright, results are in. Let's record these numbers. So for initial sequential writes, we've got this. And I'll round that up to 7. So I'll record that as 487. For sequential reads, got this. I'll record that as 906. And for random writes, record that as 396. And for random reads, record that as 79. Okay, let's go ahead and destroy this pool, and then we're going to recreate it now with all 16 hard drives. Okay, so that will be B through Q. Create our data set. And there we have it. Alright, let's go ahead and run our DD test. Okay, drop cache and read it back. Alright, so we got 709 on the initial write and 1.7, so let's figure that as 1741. Alright, let's run IO zone. Okay, results are done. Let's see what we got. So record that as 674 for the initial write. For the sequential read, record that as 1516. And for the random writes, record that as 634. And random reads will record that as 71. Okay, so in this case we see that the addition of 8 more hard drives in this RAIDZ2 set scales up the writes a little bit in sequential writes. We see that both in IO zone and the DD test. Scales up significantly for the sequential reads. We see that both in the DD test and the IO zone. And similarly, we scale up the random writes, and random reads remains at the performance level of roughly a single drive. Alright, so next, well, before I go to the next one, let's actually take a look at how this compares with the dual controller setup. So we got about 700 here, 700, it's about the same, so about 1700-ish. Maybe a little bit higher in the sequential read area. Let's see what IO zone says on that too. So we had 1425 before, 1516. So yeah, we actually have a slight improvement in the sequential reads. Sequential writes at 674, 652. So yeah, that's about the same. And random writes was 641 before, and we're at a little bit lower, 634. So it's more or less the same. So as far as RAIDZ2 goes, having the backplane really doesn't make any difference versus a 2-controller configuration. Alright, let's go ahead and do the dual RAIDZ2 setup, where we have 2 sets of 8-drive RAIDZ2s put together in the same pool. Alright, let's go ahead and do that now. So we're gonna do a, oops, it's not that one. Okay. We're gonna do a RAIDZ2 set for the first 8 hard drives, which is through I. And then we're gonna do another RAIDZ2 set for J through Q. Okay. Create our testing data set. Alright. Let me start up IOStat. Alright, here we go. Okay, drop caches, and we're going to read that back. Alright, so we got 773, and we got 1.6 gigabytes. So let's record that as 1.6 gigabytes, yeah, we'll record that as 1638. Alright, let's run IO zone now. Okay, so we're done with that. Let's go ahead and put these numbers in. So for sequential writes, we got about 704. For sequential reads, got 1670. For random reads, got 657. For sorry, that was random reads, writes. These are random reads. Round that up. And I'll record that as 80. Alright, so those are our results. Let's take a look at how they compare here. So I'm going to put, let me change this title here. Edit, chart title. Okay, so this is for controller plus expander. Okay, put that on this side, and let's see if we can put these side by side here. Alright, I don't have enough width for this, but let's see if we can compare. Alright, well, this is the best I can do. So, alright, so on the right side here is where we have a single controller and an expander. On the left side, we have two controllers. Well, some of these tests are with one controller, but some of these tests are with two controllers. And so if you look at the numbers here, the only significant difference you really see is with the RAID 0, the 16 drive RAID 0 set. So let me see if I can move this over a little bit, move that over a little bit. Okay, so yeah, in the 16 drive RAID 0, we see the sequential writes are a little bit higher with a single controller and an expander instead versus the dual controller. But otherwise, it's more or less the same, except where there's a significant difference is the random writes. This is about 1200 for the single controller and expander, and we had about 1400 for the dual controller. And I would probably speculate that that's because with two controllers, you can probably handle higher IOPS versus a single controller through an expander. And so with the random access, the IOPS does help. And so we see basically about 200, a little over 200 megabytes per second more with a dual controller setup. And you'll kind of see similarly with the RAID Z2 setups that, well, let's see. Let's take a look at this. So that's about the same. That's about the same, that's about the same, that's about the same. Yeah, so with RAID Z2 on 8 drives, there really isn't much of a difference. With RAID Z2 with 16 drives, the single control with backplane on sequential read and write seemed to be a little bit faster, at least with the DD test, and also with the IO zone test, it is actually slightly higher, and enough that it might not just be kind of random variance in testing, because we're talking about 1425 to 1516, so that's almost 90 megabytes more throughput there. And similarly for sequential writes, it's well, a little bit more. When it comes to random, it's a little bit less. Random I/O is a little bit higher with the dual controller setup, which is kind of expected. But that difference is so insignificant that it's hard to tell whether that's really because of the dual controller, or it's just, you know, random variance in testing. Okay, let's look at the two RAIDZ2 sets. We're looking at random IO is basically about the same, or actually a little bit higher on this single controller setup. So, you know, again, that's not significantly higher, but it does look a little bit higher. And a little bit, oh sorry, that was sequential reads. Sorry, I'm looking at the wrong numbers. Alright, let's look at random writes versus random writes. And, oh okay, so this is a little bit higher on the dual controller setup than the single controller setup, which is kind of expected, but not by much. So when it comes to RAIDZ2 and all the overhead of what, you know, RAIDZ2 does with parity and what ZFS does in general with, you know, checksums and everything, the dual controller does seem to give you a little bit higher IOPS, so all the random write numbers are slightly higher, but with the overhead of RAIDZ2, you know, that doesn't really account for much. It accounts for a little bit, but not much. You only really see a significant boost when you kind of get rid of ZFS and just do plain RAID 0. You do see a significant boost in random write access. Now, with the sequential stuff, it's more or less the same, except that, yeah, so sequential writes looks like a little bit higher, but not by much. Sequential reads looks a little bit lower with the backplane expander, and sequential writes, same thing here, a little bit lower here, versus in the DD was a little bit higher. So again, this is probably all just random variance in testing. Sequential reads slightly higher, but again, not significantly. So what we can conclude here is that basically with a single controller and a expander backplane, you're really not losing much in terms of performance. It's more or less the same. The only place where it might make a difference is in random access. Having the dual controllers might give you slightly higher IOPS, or at least that's how I'm speculating on how to explain this difference here. But then, you know, that's with RAID 0, which is not the most practical scenario. When you start using RAID Z2, or, you know, if you were using non-ZFS stuff like RAID 5 or RAID 6, that slight higher IOPS advantage is still there, but is mostly negated by the overhead of what you're doing with the parity overhead of doing, you know, RAID Z2 or RAID 6. In this case, I'm not using software RAID 6, which might be an interesting test to do, but either way, the difference in the IOPS capacity of two controllers is more or less negated in this kind of double parity setup, and so it really doesn't gain you that much. So in the end, it seems like with a single controller and a backplane, you more or less get the same type of performance level, at least for these tests that I'm running here. You really don't gain that much, other than potentially if you were running RAID 0 across 16 hard drives, you know, your random writes might be a bit higher. So anyway, that's the conclusion there. If you find this video useful and you liked it, please click on like. If you want to see more videos from me, please remember to subscribe. And again, if you're building your own servers and you need some parts like IT mode HBAs, please check out my eBay store called The Art of Server, and I'll leave a link in the description to my store there. And thank you very much.